In this video, we're going to look at mathematical proof. We are going to use proof by deduction, and that means we're going to use clear, logical, usually algebraic steps to show that something is true. So the question says, the first one, prove that the sum of two consecutive odd numbers is always a multiple of 4. So two consecutive odd numbers. So one odd number we can say is an even number, 2n, plus 1. So that's an odd number. We want the sum of that and the next odd number. So the next odd number is going to be 2 more than 2n plus 1. So 2n plus 3. So 2n plus 1 is an odd number, and the odd number after it is 2n plus 3. We're going to add them together. 2n plus 2n is 4n. 1 plus 3 is 4. So I've got 4n plus 4. That is a multiple of 4 because I can factorize the 4 out of it. So we've shown that the sum of two consecutive odd numbers can be written as 4 times n plus 1. So I write, therefore, the sum of two consecutive odd numbers is always a multiple of 4. Okay, one for you to try. Give that one a go. Prove that the sum of 3 consecutive even numbers is always a multiple of 6. So we can have an even number as 2n. The next even number will be 2n plus 2. And the next even number, 2n plus 4. So 2 more, and then 2 more again. So if we add this up, we've got 6n's plus 6, which is the same as 6 times n plus 1. So we can factorize a 6 out of it, so it must be a multiple of 6. Therefore, the sum of 3 consecutive even numbers is always a multiple of 6. In this question, we have an identity. So the question says, prove that 2x plus 3 times x minus 5 times x plus 1 is equivalent to 2x cubed minus 5x squared minus 22x minus 15. So this equivalent symbol means that the left side is identical to the right side. So this isn't an equation. We're not trying to solve. We can show that the left side can be turned into the right side. So what we have to do in these questions is just take one of the sides and turn it into the other side. So we're going to do 2x plus 3 times x minus 5 times x plus 1. If we expand and simplify this, we should get to the right side. So let's just expand these brackets. So we've got 2x squared minus 10x plus 3x minus 15 times x plus 1. So simplifying, negative 10 plus 3 is negative 7. And expand again, so 2x cubed times x, 2x squared times x is 2x cubed, 2x squared times 1 is 2x squared, negative 7 times x, negative 7x squared, negative 7x times 1 is negative 7x, negative 15 times x is negative 15x, And negative 15 times 1 is negative 15. And then collecting the like terms, we get 2x cubed minus 5x squared minus 22x minus 15. So we have proved it. And we need to end with a statement to say we're finished. So therefore, 2x plus 3 times x minus 5 times x plus 1 is equivalent to 2x cubed minus 5x squared minus 22x minus 15. Okay, one for you to try. So give that one a go. So again, we're going to take the left side and we're going to turn it into the right side. So we have x plus 1 over x cubed. So times x plus 1 over x times x plus 1 over x. Expand the first two brackets. So x times x is x squared. X times 1 over x is 1. 1 over x times x is 1. And 1 over x times 1 over x, 1 over x squared. Collecting the like terms, we have x squared plus 2 plus 1 over x squared times by x plus 1 over x again. Expand and simplify again. So x squared times x is x cubed. X squared times 1 over x is going to be x. 2 times x, 2x. 2 times 1 over x is 2 over x. 1 over x squared times x is 1 over x. And 1 over x squared times 1 over x is 1 over x cubed. Collecting the like terms, we've got 3x's plus 3 over x. And that is the same as the right side. So therefore, they are equivalent. They are identical. X plus 1 over x cubed is equivalent to x cubed plus 3x plus 3 over x plus 1 over x cubed. Prove that 2n squared plus 4n plus 3 is positive for all values of n. How can we show it's positive? So it's a quadratic. We can show it's always positive. So if a quadratic's always positive, it's going to have, well, we could say its minimum point is positive. That would work. So we can complete the square, find the minimum point, and say it's positive. So let's complete the square. So I want to factorize out a 2 to start with. So I'll take 2 on the outside, and that'll leave me with n squared plus 2n. I'll leave the 3 out. I could have included it inside the bracket, but I'm going to leave it on the outside. I'm going to complete the square on this middle bit on n squared plus 2n. So I've still got 2 on the outside. I'm going to do a big bracket. And then n squared plus 2n is the same as n plus 1 squared, halving the 2. Take away 1 squared, which is 1. And then I've still got the plus 3 on the outside. So n plus 1 squared minus 1 is the same as n squared plus 2n. Now I'm going to expand my big bracket. So I've got 2 times n plus 1 squared minus 2 and plus 3, which is the same as 2 times n plus 1 squared plus 1. So now I can write down the minimum point. The minimum point is what makes the bracket 0, -1. And what's left when that is equal to 0? So it'll be 0 here. 2 times 0 is 0, plus 1 is 1. So the minimum point is at -1, 1. So on the graph of y equals, 2n squared plus 4n plus 3. The minimum point is, well, it'll just be on this side at negative 1, 1. So the minimum point is at negative 1, 1. It's a positive shape, positive quadratic. The positive quadratic, its lowest point's at 1. Therefore, 2n squared plus 4n plus 3 is positive for all values of n. One for you to try, so give that one a go. So again, we can complete the square. So just half the negative 2, which become negative 1. Take away that squared. So we've got n minus 1 squared plus 2 this time. The minimum point will be at 1, 2. And again, so its minimum point is up here. It's a positive quadratic, which means it's a U shape. If it was a negative quadratic, it wouldn't always be positive. So the minimum point's at 1, 2, and it's a positive quadratic. Therefore, n squared minus 2n plus 3 is positive for all values of n. Prove that the triangle ABC with A at 1, 2, B at negative 2, 1, and C negative 4, 7 is a right angle triangle. So there's two ways of doing this one, really. We could show that Pythagoras works for this triangle. So show that a squared plus b squared equals c squared. Or we could show that two of the lines are perpendicular. And so find their gradients, show that two are perpendicular, and that would also make it a right angle triangle. So either one of those methods. Let's find the gradients. So AB, the line AB, the gradient is going to be the change in y over the change in x. Let's have x1, y1, x2, y2. So the gradient is y2 minus y1, 1 minus 2, over x2 minus x1, negative 2 take away 1. That's negative 1 over negative 3, which is a third. And then the line A to C. We'll keep x1, y1. Let's have x2, y2. So the gradient, y2 minus y1. So that's 7 minus 2 over x2 minus x1, negative 4 minus 1. That's 5 over negative 5, which is negative 1. And the other line is B to C. Let's have x1, y1, and then x2, y2. So the gradient, change in y over change in x, y2 minus y1 over x2 minus x1. So we have 6 over negative 4 plus 2, negative 2, which is 6 over 2 is 3, it's negative, so negative 3. So we've got the three gradients, which two are perpendicular. So 1/3 and negative 3 are perpendicular. One's the negative reciprocal of the other. And if they're perpendicular, they multiply to make negative 1. So we need a statement at the end. So AB and BC are perpendicular. Therefore, ABC is a right-angled triangle. It's got a right angle, so it's a right-angled triangle. One for you to try. So give that one a go. So again, you can use the gradients, or you could show that, find the lengths of the lines and show that Pythagoras applies. So either one. I'll just do the gradients again. So A, B, x1, y1, x2, y2. The gradient is the change in y over the change in x. So 4 take away 1, y2 minus y1 over x2 minus x1. 3 over 1 is 3. For BC, let's have x1, y1, x2, y2. Change in y over the change in x. So y2 minus y1 over x2 minus x1. That's 2 over negative 6, which is minus a third. So we've actually already got the two perpendicular lines. I will just do AC as well. So x1, y1, x2, y2. So the change in y, 2 minus 1, over the change in x, 9 minus 2, which is 1/7. So because 3 times minus a third equals negative 1, that means AB and BC are perpendicular. That means it's a 90-degree angle. Therefore, ABC is a right-angled triangle.